To understand this question, we first must understand the concept of constant motion. Constant motion. Okay. So what is constant motion? Or how do you deal with constant motion? And concept of constant motion specifically for pulley system. For pulley system. Okay. We'll only focus on pulley system out here. So suppose most of you have seen the pulley diagram, but this was M1, this was M2. Okay. See, if the acceleration of M1 was A1 downward, the acceleration of M2 was A2 upward, you can simply say that both the acceleration was same. So A1 is equals to A and A2 is equals to A. Then what is to do is to draw the free body diagram. But note out here, we have taken the magnitude of both the acceleration as A. Okay, and then is to draw our equation of free body diagram. Okay, but what if I do a pulley system that looks like this? But there is a pulley, there is mass M1, and from this pulley there's another pulley that is attached to this block. Okay, and this pulley is attached to mass M2. Okay, out here A1 is equals to A2. Let's out here the acceleration of A1 and this is the acceleration of A2. Out here, will the acceleration of A1 be equals to A2? No, this is incorrect out here. So how do we determine the acceleration, or how do we determine the relation between A1 and A2, A1 and A2, and what is the concept behind it? See, the concept behind it will be discussed in theory chapters, but I'll tell you the formula that is used to derive the relation between A1 and A2. Okay, the relation is net summation of T dot A is equals to 0, or net summation of tension into acceleration acting on the body is equals to 0. Okay, or net summation of T dot V is equals to 0, or net summation of T dot displacement is equals to 0, where V is velocity, A is acceleration, and X is displacement. But how do I apply this formula? I know the formula. Okay, but how are these formulas applied out here? See out here. Okay, in M1 there is a tension force T, and in M2 there is a tension force T. Out here in M1 there is a tension force T. If the rope is same, the tension throughout the wire will be same. So out here also tension would be T, and out here also tension would be T. And this pulley is being pulled up by 2T, T out here and T out here. So the tension out here would be 2T. This much is understood. Okay. Now my question is, how do I apply this formula out here? See, in this equation, okay, T is upward, A is downward. So T into A1 into cos 180. Why cos 180? Because the angle between T and A1 is 180 degree. Plus T into A2. T into A2. T into A2. Cos 0. Why cos 0? Because the angle between T and A2 is equals to 0. Both are in the same direction. Is equals to 0. If I solve this, cos 180 is equals to minus 1. Cos 0 is equals to 1. Okay. Now, so minus TA1 plus TA2 is equals to 0. If I take T common and cancel it out, I'll get A1 is equals to A2, or magnitude of A1 is equals to magnitude of A2. Okay. Similarly, if I do the same thing out here, what do I get? T into A1 into cos 0, okay, plus 2T tension always acts away from the body, into A2, into A2, into cos 180. Why cos 180? Because the angle between tension and acceleration is equals to 180 degree, is equals to 0. Okay, so out here this is 1, this is -1. Okay, so TA1 minus 2TA2 is equals to 0. So if I cancel the T out, I'll get A1 is equals to twice of A2. Okay, or A1 is equals to twice of A2. So whatever the acceleration will be of this body will have twice the acceleration of this body. But the magnitude of acceleration of this body will be twice of this body. Okay, fair and fine. And see, this relation of acceleration is also valid for velocity. That means at any point of instant, velocity of v1 would be twice of velocity of v2, and displacement of x1. Okay, suppose if this moves 1 meter downward, this will move twice of that 1 meter downward, so this will move 2 meter upward, or x is equals to x1 is equals to 2x2. Okay, similarly out here in this diagram, if at certain point velocity is v1 downward, this will have velocity v2 upward, where v1 is equals to v2. Both the bodies will have the same velocity, so v1 is equals to v2. And for a certain time, if it moves 1 meter downward, this will move 1 meter upward, so x1 is equals to x2, x1 is equals to x2. This is the concept of constant motion in pulley system. Okay, by using this concept we'll solve this problem. Okay, so what this question is basically saying is that there is one block, there is another block. Okay, if the mass of the first block is m, the mass of the second block is n times mass of the first block. Okay, the surfaces are frictionless, and find out the acceleration of block 2. Find out the acceleration of block 2 given as omega out here. This is basically the question. So how do I solve it? I solve it using the same principle. Outer tension is equals to T. Outer tension would be equals to T, because both of them are the same wire. So this 2 tension will get compounded out here. It will become 2T. 2T. And outer tension will be 2T. So if the acceleration of this block, or M1, is A1, okay, A1, I need to find out the relation between A1 and omega. Then I can draw out the free body diagram. No? Okay. So how do I draw the relation? 2T into A1 plus T into omega cos 180. Why cos 180? Because T and omega are in opposite direction, is equals to 0. Okay, or out here, T and T would get cancelled. Cos 180 is equals to -1, or omega is equals to 2A1, or A1 is equals to omega by 2. So if the acceleration of this is omega, the acceleration of this block would be omega by 2, is equals to omega by 2. Understood? Not omega, w by 2. Irodov usually uses this symbol for acceleration. Okay. Now let's draw the free body diagram for the block on inclined plane. This is 2T, and this side force is mg sine alpha. Mg sine alpha. And outer acceleration is omega by 2. And outer mass is f. So if I write down the equation, 2T minus mg sine alpha is equals to m omega by 2. Okay, this is equation number 1. And the other equation is n into m, out here tension T, out here mg. Okay, so and the acceleration is omega. So mg minus T is equals to n m into omega. This is our equation number 2. See, now you have to solve this 2 equation and find out the value of omega. But I have a problem out here. See, this is 2T, this is T. So in order to solve this equation, I can multiply this equation by 2. So I'm multiplying this equation by 2. So 2mg minus 2t is equals to 2nm omega. Okay, and I'm solving these two equation, this equation and this equation. 2mg minus 2t is equals to 2nm omega. This is our equation number 2. If I solve it, minus 2t plus 2t gets cancelled. So it equals to 2mg minus mg sine alpha m omega by 2 plus 2n m omega. I'm erasing this part, okay? Because the equation I already wrote out here. Now, can I take mg common from left hand side? If I take mg common from left hand side, it would be 2 minus sine alpha. Okay, acha, 2 nmg. Out here nmg. I was missing nmg. So 2 nmg. Why? Because the mass is only nm. Okay. So 2n minus, so out here it would be 2n mg minus mg sine alpha. Okay. So out here it would be 2n minus sine alpha is equals to, can I take m omega common from left hand side? Sorry, right hand side. So it is equals to m omega 1 by 2 plus 2n. 1 by 2 plus 2n. Okay. I can cancel out the m gets cancelled. So, okay. And out here, I can take the LCM, okay, as 2. So 1 by 2 plus 2n is nothing but 1 plus 4n by 2. So out here, I can rewrite this as 1 plus 4n by 2. Taking the LCM test, okay, I can multiply these two out here. Is equals to 2, so we get erased. Okay, and I can divide this entire term out here. So 1 by 4n, 1 plus 4n. So this is nothing but the acceleration of the block. Okay, or acceleration of the block is given by this value, twice of g 2n minus sine alpha plus divided by 1 plus 4n. Okay, now for this question we apply the same principle. The question out here is saying this block m naught, okay, is sliding over a frictionless plane. It is suspended over a pulley to m1 and m2. Now the question is asking, find out the acceleration of mass m1. Okay, you have to find out the value of a1. So how do I solve it? I apply the same constant motion. Okay, a1, a2. The acceleration of mass m2 is given as a2, and the acceleration of mass m0 is given as a0. Now there are a few questions I might have. Why is the direction of a2 not opposite to the direction of a1? Okay, out here, see, this a1 and a2 are from the frame of reference of ground. Okay, usually in your free body diagram you used to have something like this, so out here m1, out here m2. Okay, if this was moving up with acceleration a, this would be moving down with acceleration a. But out here that doesn't happen. Why? Why is the magnitude of a1 and a2 different? Because the pulley out here was fixed, but the pulley out here was itself moving. Okay, so out here the relative acceleration of m1 with respect to this pulley and m2 with respect to the pulley are same. But from the frame of reference of ground, a1 and a2 would be, the magnitude of a1 and a2 would be different. Understood? So simply without involving ourselves in frame of reference, we can solve this problem from the frame of reference also. But now you understood constant motion, so let's solve this using constant motion. Tt, out here 2t, and out here 2t. So can I say 2t into a naught plus t into a1 into cos 180. Why? Because t and a1 are in 180-degree apart, plus t a2 cos 180 is equals to 0. Acha, cos 180 is nothing but minus 1. So out here we get the relation 2t naught. Acha, you can cancel out the t, but you get the relation 2a naught minus a1 minus a2 is equals to 0. Okay, when you solve this apart, or when you solve this value, I get the relation. The relation is given as a naught is equals to a1 plus a2 divided by 2. Out here, see, we send this to the right hand side and divided by 2. So out here a naught is equals to a1 plus a2 divided by 2. And all the acceleration I'm drawing are from the frame of reference of ground. Okay. Now let's draw the free body diagram. Block mass m naught is moving with acceleration a1 plus a2 divided by 2. Okay, and out here force is 2t. m1, out here acceleration is a1. So some of you have one more doubt. Why is the acceleration of a1 downward and a2 also downward? Why not upward? See, if you apply the constant motion out here, okay, the sign of a2 would automatically determine it is upward or downward. It does not depend. Okay, so out here t m1g, that means if there were variables in the question, variables means if the values of m0, m1 and m2 are given, it does not matter in what direction you apply the value of a2. If your assumed direction, or if the answer comes out to be negative, that means your assumed direction is wrong and you change the direction vector of the acceleration. Okay, so out here let's focus on the problem. And out here m2 would be a2 downward, out here m2g t. So let's write down the equation. 2t is equals to m0 into a1 plus a2 divided by 2. Out here this is equation number 1. Out here m1g minus t would be m1a1. This is equation number 2. And equation number 3 is m2g minus t is equals to m2a2. Okay, now using these three equation we have to find out the value of a1. We have to find out the value of a1. So how do we do? See, our main, see, in most of your solutions or places, I haven't seen anyone solve the equation. The basic construct of the equation is you have to dissipate the variables. So what are the variables I do not need out here? The variables I do not need out here are this t and this a2. Okay, I do not need t and a2. Okay, so can I dissipate this equation? How many equations are there? 3 equations. And how many variables are there? 3 variables, t, a1, a2, and 3 equations. So I need to solve this one. Okay, the basic construct of solving this equation is, first I need to solve all 1 to 3, adding 1 to 3. Okay, adding equation 1, 2, and 3 and getting a. Getting a. What do I mean by that? That means 2t is equals to m naught a1 plus a2 divided by 2 m1g minus t is equals to m1 a1 and m2g minus t is equals to m2 a2. Okay, so if you add these three values, what do I get? T and minus t plus 2t gets cancelled, so it becomes m1g plus m2g, okay, is equals to m naught into a1 plus a2 divided by 2 plus m1 a1 plus m2 a2. Okay, so this is nothing but our a. Okay, let's write our a neat and clean on the next page. Our second step of the equation is subtracting a, sorry, not a, 2 minus 3. 2 minus 3 and getting b, and getting b. Okay, so I subtracted this equation from this equation. Okay, so 2 this equation minus this equation. So how do I do it? m1g minus t would be m1 a1, and out here m2g minus t would be m2 a2, but out here you have to multiply by minus. So out here t and my t would get cancelled. So m1g minus m2g would be m1 a1 minus m2 a2. This is our equation number b. Okay, so first step was adding all the three equations and getting equation a, and second step was subtracting 2 minus 3 and getting b. Now we'll solve a and b, okay, to get our answer of a1. What you are calculating? You are calculating the answer of a1. See, from this equation, can you see that I eliminated the value of t? Okay, now there are two equations and two variables, a1 a2. Okay, a1 a2. See, we obtained equation a and b. See, what my main objective was to eliminate the variable of t. Okay, now what do I do? I have to eliminate the variable of a2. How do I do that? So out here m2 a2 from equation b, okay, or m2 a2 is equals to m1 a1 minus m1g plus m2g. What did I do? I send this m2 a2 to the left hand side and all these variables to the right hand side. Okay, so m2 a2 is equals to this value, and from this equation only can I say a2 is equals to m1 a1 by m2 minus m1g by m2 plus m2g by m2. Okay, what I did out here is divide this entire right hand side divided by m2, or a2 is equals to this value. Now I have to substitute this m2 a2 out here and a2 out here. Okay, from equation b I obtained two parameters. I have to substitute these parameters m2 a2 out here and a2 out here. Okay, so let us take all the terms that are out here. So equation number a, m1g plus m2g is equals to m naught a1 divided by 2 plus m1 a1. I'm writing all the a terms together now, plus m naught plus m2 a2 plus m2 a2 can be written as this value. So plus m1 a1 minus m1g plus m2g. Okay, so this value is done, plus m naught a2 by 2. Okay, plus m naught by 2, and what's the value of a2? The value of a2 is m1 a1 by m2 minus m1g by m2 plus m2g by m2. Okay, so this is the thing that has been done. Now let us simplify the equation. See, out here plus m2g on the right hand side and plus m2g on the left hand side would get cancelled. So let's cancel them. Okay, this m1g minus m1g would go on the left hand side and get added to this m1g, and it would be 2 m1g. Okay, So out here 2m1g and this entire thing is cancelled. So out here 2m1g, 2m1g. Okay, m2g is cancelled. So 2m1g. Okay, this m1a1 and this m1a1 would get added and become 2m1a1. So this is nothing but 2m1a1. Okay, so I just simplified this one. So my next process is isolate the variable of a1 on the right hand side and send all the remaining variables to the left hand side, because I need to have the value of a1. By combining a and b, what I did was I dissipate the variable of a2. Now after dissipating the variable of a2, I need to isolate the variable of a1 from this entire equation, no? So I'm doing that. So I'll take 2m1g, okay, minus, see, does this equation have the variable of a1? Okay, it stays this side. This, no, so it goes to the left hand side. So minus goes to the left hand side and becomes plus m0 by 2 into m1 by m2 into g. Does this contain the variable of a1? No, so it goes to the left hand side. So plus goes to the left hand side and becomes minus and becomes m0 by 2 into m2 by m2. M2 by M2 get cancelled, no? Okay, so it becomes G. Okay, so these variables and these variables are sent to the left hand side, who should be equals to the remaining variables m0 a1 by 2 plus 2 m1 a1 plus m0 m1 a1 by 2 m2. Okay, now I can take G common from the right hand side and a1 common from the left hand side. So if I take G common from the right hand side, I'll take 2m1, or let's solve the equation out here. Okay, I'm taking G common from right hand side, sorry, left hand side. So left hand side G, so all the G will get erased. Okay, I'm taking a1 common from the right hand side, so a1, all the a1s will get erased. Okay, now let's write this equation neat and clean. That means I'm compressing this equation to m1 plus m0 m1 by 2m2 minus m0 by 2 into G is equals to m0 by 2 plus 2m1 plus m0 m1 by 2m2 into a1. Okay, what else can I do? See, can I multiply out here? See, 2m1, 2m1, can I multiply the numerator by 2 and divide it by 2? So this can be written as 4m1 by 2. 2m1, see, 2m1 can be made as 4m1 by 2, no? So I'm doing the same thing out here. 2m1 is nothing but 4m1 by 2. What I'm trying to do is I'm trying to make all the denominator 2 and cancel out the 2. Similarly out here 4m1 by 2, 4m1 by 2. Okay, now can I multiply m2 on the numerator and m2 on the denominator? Of course I can. So m2 m2, out here already m2 is there, m2 m2, out here m2 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 m2, and out here m2 is already there. So can I cancel out the 2m2 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 from left hand side and right hand side? Of course I can. So let's make this little bit neat and clean. I'm erasing all these values. Let me also erase the previous step out here and draw. Now let's write this equation out here. 4m1 m2 plus m naught m1 minus m naught m2 into g is equals to m naught m2 plus 4 m1 m2 plus m naught m1 into a1. So a1 is equals to 4 m1 m2 plus m naught m1 minus m naught m2 into g. You can see the similarity in the answer. Okay, divided by 4 m1 m2 plus m naught m2 plus m naught m1 is equals to a1. Okay, so out here I can take m naught common. Okay, out here I could take m naught common. Let me erase this one. Solving with the equation plus acha, m naught into m1 minus m2. Okay, this equation was only out here, no? So I'm taking m naught common. So m1 minus m2, m naught into m1 minus m2. Similarly out here, I'm taking m naught common in these two equation. So m naught into m2 plus m1. So m naught into m1 plus m2. This is the answer given in your book. Okay, so this is the acceleration of a1. It was not necessary to solve the entire equation, but just so that it becomes much more easier. Okay, I could leave the equation, I could have left the question just by giving you the gist of three equations. Okay, so just solve the equation so that you will have easier things to do. See, what this question is saying is that there is a pulley out here. Okay, and one end of the pulley is connected to a rod of length L. The length of this rod is L. And the other end of the pulley is connected to a ring. Out here there is a ring of mass M. And this ring is allowed to slip up and down, okay, along this rope. Now the question is saying after a certain while the system becomes like this. See, if I leave this system, what will become? This mass will come down and this ring will also move down because it is allowed to slip, no? Okay, so after a certain while this mass moves down a certain length, okay, with its own acceleration, and the ring also moved down a certain length, and the ring reached out here, ring of mass small m reached out here. Okay, that means initially the lower end of the rod was aligned with the ring. At final, the upper end of the rod was aligned with the ring. And the question is saying the time taken to do this is equals to t. Okay, the time taken from to go from here to here is equals to t. Then the question is saying find the friction force. That means out here in this ring, a friction force will act, no? So find the friction force on that. Okay, so out here, if I assume the acceleration of block mass m, capital M, to be capital A, okay, and out here mass of small m to be small a, just tell me one thing: is capital A is equals to small a? Can I apply E dot T dot A is equals to 0 out here? No. Why? Because out here in that whenever I was applying this formula, no, the formula was derived on the assumption, okay, that the length of the string between two contacts remains same. That means this length plus this length will remain same. But out here, this ring is allowed to slip, no? So if this ring is allowed to slip, does the length of the string between two point of contacts remain same? After a certain one, what will become? This ring will slip down, so the length of the rope will become more large, no? So the length of the string is not fixed. So this should not be valid. So whenever you are applying this formula, make sure that the length of the string between two points are constant. Okay, So now let's draw the free body diagram of the rod of mass m that is moving down with acceleration a. Okay, upward is tension force, downward is mg force. And let's draw the free body diagram of ring of mass m. Down is mg, upward is friction. Okay, it is moving down with acceleration a. Now see, this friction force will always act in upward direction. Why? Because the ring is always trying to slip down. See, even if the block doesn't move, either the rope moves up or the ring slips down. In both the cases, what is the direction of friction force? What is the direction of relative motion? The rope is trying to move up, okay, so the ring will pull it down, and the ring is trying to move down, so the rope will pull it up. So direction of friction force on the ring is always up. Okay, now listen to me. What if I say the tension force out here is equals to friction force out here? Why? Draw the free body diagram of the ring. Sorry, pulley. Out here, this is tension force. Out here, this is friction force. Are there any other forces acting on this pulley? No. So can I say in this rope, this friction force only gets translated to tension force? So out here, tension force is equals to friction force. Now if I write down the equation, okay, what are the equation? If I write down the equation of the rod, mg minus, or let's write down the equation out here. Okay, mg minus friction force is equals to capital Ma. Okay, and from the ring, if I write down the equation of the ring, mg minus fr is equals to small m into a. These are the two equations, and what do I have to find out? I have to find out the friction force. Find out the friction force. Friction force. Okay. Now can I multiply the top equation by m? So m into friction force into m into m. And can I multiply the lower equation by capital M? M M capital M. Okay. So out here, if I cancel this out here, lower friction force was capital M. Okay. Now what can I cancel? I can cancel this out. Means out here minus, this becomes plus, this becomes minus. Okay. So out here, this value and this value gets cancelled. So FR, friction force, into capital M minus small m is equals to m capital M into small m into A minus A. Okay. Or if I draw out the friction force is equals to capital M into small m into A minus A, or acceleration of block minus acceleration of ring, divided by mass of block minus mass of ring. Now see in this question, this A minus A is a term out here. Okay, I have to substitute this A minus A in terms of time t, because the time t is given in the question. Okay, how do I do that? So if I say, see, if I say from this position to this position, the time taken is t. Okay, so what is the relative acceleration as observed from the frame of the ring? If I put my observer out here, okay, or if I put my observer on the top of the block, okay, what is the relative acceleration of the ring? The relative acceleration of the ring would be capital M minus A. Okay, relative acceleration would be capital A minus A. Okay. Since I'm trying to move upwards, if I put the observer on the ring, okay, the ring has to move downward. So it's better if I put my observer on the ring out here. So out here, from this observer, okay, relative acceleration of the block would be capital A minus small a. Okay, so this observer is watching the ring slip down. Okay, what is the distance? What is the relative distance it has to slip down? L. So relative distance is equals to L. What is the initial velocity? Initial velocity was equals to 0 because the system was held at rest. So can I apply S is equals to ut plus half at square? S is equals to ut plus half at square. Okay. So initial velocity is equals to 0, distance needed to be traveled is equals to L. Acceleration or acceleration relative is equals to capital A minus small a into t square. But t is the time taken to cover the distance L. Okay. So out here from this equation, can I get t square is equals to, or see, 2L by a minus a is equals to t square. 2L by t square is equals to a minus a, capital A minus small a. See, send this 2 to the left hand side, send this 2 square below. So 2L by t square is equals to capital A minus small a. And can I substitute this capital A minus small a out here? Of course I can. So the value of friction force would be, I'm substituting out here, 2L by t square. The value of friction force is nothing but capital M into small m divided by capital M minus small m into 2L by t square. 2L by t square. This is our answer. Understood? Now what this question is saying is that there is a ball out here connected to a rope. Okay, and this pulley is connected to a rod of mass m. Rod of mass m. And if the rod has mass m, the rod of the ball connected out here has mass n times of m. That is the question. And this rod has a total length of L. Now suppose I say the acceleration of this rod is A, downward. Okay, can I say is T dot A is equals to 0 applicable out here? Can I apply E T dot A is equals to 0 out here? Yes. Why? Because unlike previous question, out here the length of this string plus the length of this string will always remain constant. Doesn't matter how the block moves. See, unlike previous question, the ring was allowed to slip, no? But out here, the length of this string plus the length of this string will always remain constant because the ball out here is fixed to this wire. Okay, so if the length of this rod is equals to A rod, right? A rod. Okay, and the acceleration of this ball is equals to AB. What is the relation between acceleration out here and acceleration out here? Acceleration out here and acceleration out here. So let me apply T dot A. Okay, so out here there is a tension force. Out here there is a tension force. These two tension force would combine to become 2T out here. So this 2T would get applied out here. So can I say 2T into acceleration of ball, okay, is equals to my or minus T into acceleration of block is equals to 0, or acceleration of block is equals to acceleration of acceleration of ball is equals to acceleration of block divided by 2. So out here, if this is moving down with acceleration A, this will move up with acceleration A by 2. So out here AB is equals to A by 2. Let me just erase this AB and make it is equals to A by 2. A by 2. Okay. Now let's draw the free body diagram. This rod has a mass m. Okay. So mg is being pulled up by t and is moving down with acceleration a. Okay. Is there any other force? No. This ball has a mass n times of the rod. Okay. It is being pulled up by 2t. It is being pulled down by gravity force of nmg, and it has an acceleration of upward acceleration of a by 2. So if I write down the equation out here, mg minus t is equals to ma. This equation comes from the block out here. 2t minus nmg is equals to nm a by 2 is equals to nm a by 2. This equation comes from the ball. Okay. If I multiply this first equation by 2, 2mg, 2t, 2ma. Why am I multiplying? To cancel out this t when both the equation. Okay. So out here, 2, can I take mg common? 2 minus n into mg is equals to, I'm taking ma common out here. 2 plus 2 plus n by 2 into ma. Okay, I'm cancelling out the m and m. So out here, acceleration is equals to how much? 2 minus ng, 2 minus n into g divided by 2 plus n by 2, 2 plus n by 2. Okay. If I take LCM out here, it will be 4 plus n divided by 2. So if I erase this out here, this becomes 4 plus n divided by 2. And I can take this 2 upward. So it would be 2g. It would be 2g into 2 minus n by 4 plus n. So the acceleration of the block downward would be 2 minus n or this one. Okay. And the acceleration of the ball would be this value divided by 2. Fair and fine. Now my question is, the question was asking is, what was the time taken by this block, okay, to cover the distance L? Okay, that means this block will come down and this ball will move up. So what is the time taken to for this block to reach the top of the cylinder? So can I say relative acceleration? If I put my observer on this block, okay, can I say relative acceleration of the ball is equals to a by 2 plus a. Why plus a? Because whenever you are taking relative acceleration, you have to take the acceleration of frame of reference and apply it in the opposite direction. Okay, so relative acceleration is equals to a by 2 is nothing but 3a by 2. And what is the value of a? The value of a is nothing but this entire value. So the time taken, how soon? So the time taken, I'm simply applying as is equals to ut plus half at square. Okay, where a is out a relative acceleration. Initial velocity is equals to 0 because the out here s is equals to L. Initial velocity is equals to 0 because all the things were the initial position, they were stagnant. They was not moving with any velocity. Okay, out here acceleration relative is equals to 3a by 2, 3a by 2, and find out the time. So out here, I'm solving the questions out here. Okay, so out here, if I write this equation, L is equals to half into 3a by 2 into t square, or t square is equals to 4L by 3a, 4L by 3a. Okay, And what is the value of A? The value of A is nothing but this value. So substitute the value of A out here. T square is equals to how much? 4L by 3 into 2 minus n into 2g divided by 4 plus n divided by 4 plus n. So this is our answer. Out here, let's simplify the answer. 2 and 2 get cut. So out here, this is being erased by 2. Okay. And out here, I found out the value of t square. No, I have to find out the value of t. So I have to take t is equals to 1 by 2 or under root of this entire value. So the time taken for this ball to move at the top of the rod is equals to this value. Now see what this question is saying is that there is a mass out here, there is a mass out here. Okay, suppose the mass of block 2 is m, then the mass of block 1 is 4 times mass of block 2. Okay, now see, this will come down with some acceleration and this will move out with some other acceleration. Okay, now as soon as this block comes down here, this block will reach up to some height. Okay, so after that height is reached, what will happen? The string out here will become loose, so there will be no tension force out here. Okay, the height till acha out right now I'm saying this block will reach 2h when this block reaches h. How did I derive this? I'll do it in the problem. But the main point I'm making out here is, will this block stop after reaching out here? No, because out here it started with zero initial velocity. It reached out here with some acceleration, but that acceleration caused the change in velocity. No, so out here when the tension is zero, it will have some velocity. Acha. Even if it has some velocity, there will be gravity forces acting downward on this block, so which will cause an acceleration of g downward. So it will reach some more height x. Now the question out here is asking, find the total height reached by the block. Okay, you have to find out the total height reached by this block as soon as these blocks come down. The initial position is this velocity is 0, this velocity is 0, and the setup is kept like this. Okay, as soon as this block reached out here, find the total height of the block or block of mass m. Understood? Now the second part of the question is the concept of t dot a applicable out here. Yes. Why? See out here. The length of this entire string will remain constant. Okay. This length will remain constant. Doesn't matter the motion of this or this. Okay. So out here, if you do t dot a, out here tension force is equals to t. Outer tension force is equals to t. Outer tension force is equals to t. So outer tension force would be equals to 2t. Okay. If the rope is same, the tension force would be same. So out here, for the block of mass 4m, can I say 2t into a minus 2t? Why? Because acceleration and tension force are in opposite direction. Is equals to plus t into a2 is equals to 0. If I cancel out the t, or a2, acceleration of block 2 is twice of block A. So this acceleration out here would be 2 times the acceleration of this value. So the acceleration out here would be equals to 2A. Understood? Now, is the same equation valid for t dot x? T dot x is equals to 0. That means I'm deriving this height to h. How did I obtain this height to h? Okay, see, let this height be y. Okay, so tension into minus 2t into h. Why? Because the displacement and the tension are in opposite direction. If the block moves down, the tension is in opposite direction. So cos 180 is nothing but minus of 1 plus t into y. Why plus t into y? Because tension and displacement are in the same direction, is equals to 0. Similarly, out here, if we cancel out the t, y is equals to 2h. So out here, till this blocks reaches out here, this small block will move up to height 2h. So this small block will move up to height 2h. Then after reaching height 2h, what will happen is this block will have some velocity. Now to find out the velocity, okay, the velocity of this block after reaching 2h. So suppose the acceleration out here was 2a. Okay, the net acceleration out here was 2a. The initial velocity out here was 0. We have to find out the final velocity out here. So can I do v is equals to u square plus is equals to u square plus 2as. Okay, the final velocity I have to find out. Initial velocity is equals to 0. Acceleration is nothing but twice of acceleration of this value, and s is nothing but, what is the value of s? 2h. Okay, so out here v square is equals to 8ah. So velocity would be out here equals to under root of 8ah. So out here velocity after reaching this point, okay, when the tension becomes loose, is equals to 8ah under root of 8ah. Okay, now after this point, okay, the tension becomes loose. What are the forces acting on this body? The forces acting on this body are only gravity forces. So the acceleration will only be acceleration due to gravity. Okay, and velocity is equals to how much? Velocity is equals to under root of 8ah. 8ah. So out here velocity is equals to 8ah. Acceleration is equals to g downward. What is the value of x? So at this point, at the topmost point, the velocity would be equals to 0. So I'm again applying v square is equals to u square plus 2. V square is equals to u square plus 2ax. Okay, out here s is nothing but the x we have to find out. Okay, a is nothing but minus g. Why minus g? Because displacement and acceleration are in the opposite direction. Okay, and u square, initial velocity square, is nothing but the velocity out here. What is the velocity out here? Under root of 8ah. So velocity square would be 8ah. 8ah. And what is the final velocity as it reaches the topmost point? The final velocity out here would be 0, no? Because for the topmost point, as the block reaches the topmost point, the velocity at topmost point would be equals to 0. Then it would start coming down, no? Then again it would come here, and then again the acceleration would change. So out here, if we solve this value, the final velocity becomes 0. If we solve this value, we get 2gx is equals to 8ah, or x is equals to 4ah by g. So x is equals to 4. So out here x is equals to 4ah by g, where a is nothing but the acceleration of the block, or initial acceleration of this block. Okay, so our net total height total height reached is equals to 2h plus x, 2h plus x, and the value of x is nothing but 4ah by g, 4ah by g. Okay, so we'll do our calculation on the next page, or let's do our calculation out here. Okay, I'm erasing this all. Now what is the value of this a? The value of this a is nothing but the initial acceleration. So let's draw the free body diagram. Out here 4m, we'll have 4mg and 2t, and out here acceleration would be a. For the smaller mass, mg, and this would be t, and this would be 2a. Okay, so I can simply do out here two sets of equation will be from mass 4m, 4mg minus 2t is equals to 4ma. This is equation 1, and from mass 2 or mass m, it would be t minus mg is equals to 2ma. Okay, I'm multiplying this equation 2 by 2. I'm multiplying this equation by 2. So 2t plus 2mg is equals to 4ma. 4ma. So out here 4ma. Why did I do that? To cancel out the t. Out here t cancels, or 2mg is equals to 4ma, or a is equals to g by 2. A is equals to g by 2. Acha, out here 8ma. 4 plus 4 is equals to 8ma. So out here a is equals to how much? G by 4. So total height reached is equals to 2h plus 4h by g into a. What is the value of a? G by 4. So out here g gets cancelled, 4 gets cancelled, is equals to 3h. So the maximum height reached by this block 2 would be 3h. So this total height is 3h. 2h out here and h out here. Okay. So total height reached is equals to 3h.